Good morning, everyone. Today we're going to talk about multiple moles. So multiple moles are just like the regular moles we did, except now we're accounting for how many moles of each individual thing there are in a molecule or a compound, as opposed to just looking at one atom or looking at the compound out all as a whole. So, for example, let's look at sodium chloride, NaCl. So I have one Na, one Cl. If I have potassium chromate, I have two potassiums, one chromium, four oxygens. If I have tin 2 hydroxide, I have one tin, two oxygens, and two hydrogens. H2O, two hydrogens, one oxygen, C6H6, six C's, six H's. Now, think of a box of pizza. If you have 7 slices of plain and 1 slice of pepperoni, you have 1 box of pizza, and in that 1 box of pizza you have 1 pepperoni and 7 plain. Now imagine we put a coefficient in front there. We say, instead of saying I have 8 moles of something, I'm going to say I have 8 boxes of pizza. So I'm talking about the total number in that pizza. So I have 8 boxes. Each box has 1 pepperoni slice. So I'm going to have 8 slices of pepperoni. And then for my plain, since there's 7 plain slices per box, I have 8 boxes. 7 times 6 is 56. So we have to account for that. So if I take these same compounds that I had over there, and these are the ones that are in the Google Doc, so if you're trying to figure out where the numbers came from, I'm going to explain that. So if I have 3 NaCl, this means I have 3 moles of sodium chloride. Now, so therefore I distribute. So I have 3 moles of sodium and 3 moles of chlorine. If I have 2 moles of potassium chromate, I'm going to do 2 times 2, so I'm going to have 4 moles of potassium, 2 times 1, 2 moles of chromium, 2 times 4, 8 moles of oxygen. Even though there's only 2 moles of the whole thing, it may sound confusing that there's more moles of the individual things, but you have to think that there are more than one thing, or there's more than one element in there if you have a subscript on there. Okay, I have 4 moles of tin 2 hydroxide. So that's 4 of the whole thing. 4 times 1 means I have 4 moles of tin. 4 times 2 means I have 8 moles of oxygen and 8 moles of hydrogen. If I have 6 moles of water, 6 times 2 is 12, so I have 12 moles of hydrogen and 6 moles of oxygen. Okay, let's turn it around and talk about some of the problems we'll use this for. So, this is number 1, 2, 9, and 10 from your worksheet, because one thing that people ask me to start doing is to use some of the questions from the worksheets. So today you only have to do 12 from the worksheet. If you're having trouble, I'd really recommend trying all 20. But hey, it's your life, it's your choice, okay? I'm going to try to color code. If you looked on the answer key, I did color code the best that I could. I don't think I messed up any, and I'll do my best here to not do that. So first step we need to look at is what are the differences. So the reason I put 1 and 2 together is if you read them, how many iron atoms are in 3 moles of iron 3 bromide, or FeBr3, and how many bromine atoms are in 3 moles of FeBr3, there's only one difference. This one says how many iron atoms, this one says how many bromine atoms. Okay? That's the only difference between the two of them. Now, in order to start a problem, I have to know what I have in the problem. There's only one number and unit there, and it's the same for both of them. That's exactly how it is on the worksheet today, how it'll be on the worksheet tomorrow, and how it'll be on the quiz on Friday. So both of them have 3 moles of FeBr3. As I said on the quiz, I will do the same thing. So if I give you H2O, if I give you 2 moles of H2O, it's going to be 2 moles of H2O for both the problem with hydrogen and with oxygen. Okay, so we always start with what we have. So let me start my parentheses. I'm going to do these together. You do not have to do them together. I just think it makes sense for a lot of people because you start seeing the patterns that come together. So I'm going to start with 3 moles of FeBr3 for both. Okay? I'm going to put placeholder 1 underneath. That 1 is just because it makes me feel better because it's even. You do not need that. You don't have to use the parentheses system if it does not work for you. You could just show me what you're doing mathematically as long as you show me some kind of work. But if you're not completely sure what you're doing, this really helps. So if you remember from either dimensional analysis or what we did earlier in moles, whatever numbering unit we have up on the top, we want to cancel out the unit. So I'm going to drop down moles of FeBr3. Okay, so let's plan a little roadmap first without even worrying about the math or the numbers yet. So I have to take moles to something. So I know I can take moles to atoms, but that's FeBr3. That's not iron or bromine. So I have to convert that. So I'm going to say how many moles of FeBr3 I convert to moles of Fe. Same thing here. How many moles of bromine do I have? I can say moles of bromine. Okay? Now let's think about what number goes there. So in FeBr3, how many Fe's do I have? I have 1, so I write 1. In FeBr3, I have how many Brs? I have 3, so I write in 3. Because in 1 mole of FeBr3, there are 3 bromines, and in 1 FeBr3, there is 1 Fe. It's not always going to come out to 1, it just happens to be that way this time. Okay? I'm going to drop my unit down, so I'm going to say moles of bromine, moles of iron. Notice the only difference so far is this one number here and what unit I'm talking about. Okay, and notice there are 3 parentheses now. That's just how this works, okay? So, I have moles of bromine. Can I take moles of bromine to atoms of bromine? Yes, I can, absolutely. 1 mole of anything equals 6.02 times 10 to the 23rd. In this case, it's atoms of bromine. Same thing here. 1 mole of anything equals 6.02 times 10 to the 23rd atoms. Okay? And here it's going to be iron. Okay? If you see molecules and atoms anywhere, it's just singular and plural. I would never take off if you mix up the two. I just want you to know that. But in case you do get confused by it, now you know. Okay. So I'm actually going to do the math with you. So remember, if you go down, you divide. If you go up, you multiply. And we can double check our units because FeBr3 and FeBr3 moles cancel out. Moles of iron cancels out. Our found unit matches. Ignore anything that's a 1. So I'm going to do 3, ignore all the 1s, times 6.02 times 10 to the 23rd. Don't do something divided by 1, something divided. You don't need to do that, okay? So I'm literally going to type in 3 times 6.02 times 10 to the 23rd. Okay? You may need parentheses around that. That's up to you. So I just did, I don't know if you can see this. Yes, you can. So I have 3 times 6.02 times 10 to the 23rd. And my answer is 1.81 times 10 to the 24th atoms. Remember, you don't put unit on the quiz, you're losing a point. If you two decimal places, please. If you go to 3, I'll live with it. Some of you are rounding to 4 decimal places. I will just mark the answer wrong. I've talked about that since the first month of school. Same thing, if there happens to be a 0. So if this was 0.81, make sure you write that 0 in. Okay, let's try the second one. So now it's not all 1. So I'm going to have 3 times 3, because everything's on the top. I don't care about the bottom. So I have 3 times 3 so far, times 6.02 times 10 to the 23rd. I'm using the exponent function on the calculator. You could do times 10 caret 23rd or whatever you have on your calculator, whatever you have on your computer calculator, your cell phone calculator, your internet calculator. If you need help processing one of those, let me know. I'll do my best to help. Okay? So I had 3 times 3, those are cut off, you saw them before, times 6.02 times 10 to the 23rd. It equals, and I'm going to get 5.418 times 10 to the 24th, which I'm going to round to 5.42 times 10 to the 24th atoms. You can write atoms of iron, atoms of bromine. I'm not going to go crazy with that. That's your choice, your prerogative. Okay? Okay. Now let's look at numbers 9 and 10. We're going to switch it up. So instead of starting with moles, now I'm starting with how many atoms I have. So, how many moles of nitrogen, that's what it's asking for, okay, are in 7.53 times 10 to the 23rd atoms of ammonia, or NH4. Okay, let's look at the second one. How many atoms of hydrogen, oops, sorry, it should say how many moles, sorry guys, typo. It's correct in your worksheet though. How many moles of hydrogen are in 7.53 times 10 to the 23rd atoms of NH4. I think there's a little bit of a glare there. Give me 1 second to turn off the extra light I have. See if that's a little bit better. Okay, so let's set up with our parentheses. Remember, you don't need to do them together. I'm choosing to do them together. Some of the ones in your worksheet might have 3 or 4 separate elements. If it helps you, do them all, because look, if you look, you set up the first parenthesis the same, the second one's almost the same, and the third parenthesis is all the same. So the only one that changes is your middle parenthesis. So if you set them up all together, it makes it easier, because if you know what you're doing, you can do them all at once. Okay? Okay, so we're going to start with 7.53 times 10 to the 23rd. And same thing, our atoms, it technically should be molecules. I think I fixed that on your worksheet. Molecules of NH4. But when you do so many problems with these, it starts blending together. Okay, 7.53 times 10 23rd molecules of NH4. Okay, MC is not an official abbreviation. I'm just using it to be lazy. Just so you guys know if you choose to take chemistry in college. Okay, put it over my placeholder 1. Over my placeholder 1. Open up my next parenthesis. Okay. What unit do I have here? I have molecules of NH4. So I'm going to need to bring down molecules of NH4. Okay. And molecules NH4. Okay. So anytime you have an exponent, generally you want to get rid of it sooner rather than later. So I have molecules. Could I do molecules and then go to atoms of that? Yes, but it's kind of messy, and you're going to have to do an extra parenthesis. So think of it this way. If you have an exponent, you want to get rid of it. So I'm going to say, okay, what can I convert molecules into? Oh, moles, because that's the only thing we've learned how to convert molecules into. So 1 mole is always equal to 6.02 times 10 to the 23rd molecules. Okay, that's equal to 1 mole of NH4. Sorry with the squeaky marker. Okay, drop the same unit down. 1 mole of NH4. 1 mole NH4. If you're ever not sure, you can always write down 1 mole, unless you know that you're talking about something different. Remember, 1 never goes with your molecules. The 1 always goes with the mole. Your 6.02 times 10 to the 23rd always goes with your molecules or atoms. Okay, so I have moles of NH4. Can I take moles of NH4 to moles of nitrogen? Sure, because 1 mole of nitrogen is in 1 mole of NH4. Same thing, 4 moles of H are in 1 mole of NH4. Okay. So for this one, we need to divide and then multiply. Remember, if you go down, you divide. If you go up, you multiply. So we're going to divide and then multiply. Okay? You can do it in 2 steps. Your calculator can handle it in 1. So I'm going to do 7.53 times 10 to the 23rd, close my parenthesis, just like that. If you need to, you can pause the video if you need to stop and type that in. divided by 6.02 times 10 to the 23rd. Okay, you can see divided in that. And then I'm going to go right into, I don't have to even do times 1. I can just hit equals right there. And this is going to give me 1.25, and my last unit I had was moles. Okay, if you're ever confused about your unit that you're finishing with, look at the question. How many moles? Okay, that's my final unit. Okay, let's try the second one. So I'm going to do 7.53 on times 10 to the 23rd divided by 6.02 times 10 to the 23rd. And then I have 4 moles right here, so I'm going to do times 4 equals 5 moles. Okay? So that's how you do these. The same rule generally applies that we learned earlier. If you have moles, you multiply. Just remember that, for some of like the ones where you start with an exponent, you may have to do both. These ones you just multiply it all the way across. If you have any questions, please shoot me an email. Our live lesson is at 10:30. I'll run through these problems again. I'll take any other questions you have from the worksheet or anything else. Hope you guys have a wonderful day. I'll catch you tomorrow.